Hello, everybody. This is Dr. Fang-Mei Law from Tiffin University. Hi, my student. I know for right now, many of you already collect the data and ready to go. Then you start to ask yourself, what should I do with this data? And it's okay if you have this worry and curious, that it's normal, because we didn't have chance to really learn about SPSS before we were sent it back home. So that's my intention for this video, to help you out. Hopefully I can make SPS get through this screen and get to your mind. Okay, so when you have data, first of all, look at your data. What kind of data you have? Okay, is your data considered nominal data or scale data? When we say nominal data, that it means, you ask people yes, no, you ask people true or false, or you have them choose the option, for example, you ask them what kind of social media they prefer, you give them a couple options, they choose. And this we call nominal data, because they are more like category, okay? But if your research question, you ask them, you have statement, you ask them from 1 to 5 to tell you, how much they agree with your statement or how much they like. All this, you can consider they have number in between. It's meaningful, and we call it a scale, okay? So then if your data is scaled, okay, this video may be suitable for you, because I'm going to talk about how do you compare different groups. Okay, but when you want to compare groups, another question I need to ask you is how many groups you have in mind. If you are compare two groups, then you need to go to my another video talk about independent t-test. If you are compare more than two groups, then this video will be suitable for you. So in this video, we are going to discuss, I will show you how to run SPSS by using OneWay ANOVA. Okay, so when we say OneWay ANOVA, that means you are compare different group, but just based on one category. Like under school level, you have 4 groups, right? So then that's what we call ANOVA. So I'm going to turn my screen back to computer so we can go from there, okay? Is everybody ready? Okay. So this is what we started, okay? So the lecture for today is how to conduct data analysis by using OneWay ANOVA. Okay, so this is the chart. You have to ask yourself, is this the right direction for you? If this is the right direction, then OneWay ANOVA is your way doing your data. Okay, but keep in mind, you can have in the same data, say you can run different statistics. This can be just for some of your questions. Okay, so if your data is scale data, you want to compare to determine the significance of the difference between 3 or more sample means on a single independent variable. Okay, as I mentioned, if you want to compare different major, then you may have for our school, we have criminal justice, and we have a business, and we have art and science, right? We consider there are three samples, right? Then you can use OneWay ANOVA. Okay, so when you start to do your data, before you even started, you need to make a hypothesis. That means you give an educational guess. Okay, so what's your guessing? Okay, you want to compare, you assume they are different. Are they different or not? Okay, So you need to set two hypotheses. Okay, so here, the first one called non-hypothesis. Non-hypothesis. Okay, that means I assume they have no difference. Okay, so here I'm going to use the data that we create in our class before we were sent back home. Remember we have that variable called attendance, right? And then we also have variable to ask people what's their class time. So they can have a morning class time or afternoon or evening, right? So they have a 3 different class time. So my null hypothesis will stay like this. There is not a significant difference in dependent variable. So for my case, it will be attendance for participants in 3 different class time. So this is null hypothesis, okay? Then opposite from your null hypothesis will be yes, I do. So they'll be saying there is a significant difference in different variables, and in my case, it's attendance for participants in 3 different class times. So this is your hypothesis you set up before you start your data analysis, okay? Then, you have to set up your significance level at 0.05. That means whenever after you do your data analysis, if their significance level is less than 0.05, I'm going to say, well, that's what I want. So you need to have a cutting point. So 0.05 also means if you run 100 times of your data, 5 times out of 100 can be occurred by chance alone, or can have some error. Okay, and as a social science researcher, we are okay with that part of mistake. Okay, but of course, if other field like medical field, they may not have tolerance for this 5 chance mistake. Okay, so but for our field, it's fine. So you have to say you set up the significance level at 0.05, and I will explain to you more detail later how you use this number for. Okay, so then let's start to run the data. Okay, I'm going to use the data set. Here I have, and I'll post in your Moodle. Okay, so you can follow along and practice. Okay, so to run your ANOVA, okay, you go to here, analyze, okay, analyze. Then you go to compare means, okay. Then you come here, call OneWay ANOVA. Everybody get that? Okay, so that's your OneWay ANOVA, okay. When you get in here, they should have nothing. They should have nothing, okay. So then you send your dependent variable, okay. In my case, it's attendance, okay. You click on attendance and send to under dependent list, okay. Then since you want to compare class time, so class time here is your factors, okay. So you send to factors, okay. Everybody got that? Okay, your attendance here under your dependent list, and then you have class time under your factor. Okay, so now after that you click on option, okay, and you click on descriptive here. Okay, so descriptive means you ask SPSS to provide you mean and standard deviation, those descriptive data, because they don't give you automatically, so you have to ask for it. When you run independently, if you watch the video already, you will see you don't need to have this step, because they are given to you automatically, but not OneWay ANOVA. So make sure you have to check this and say continue. Okay, so now you say okay. Okay, so if you look at this output, okay, okay, you'll see they have 3 charts they provide to us. Okay, they give to us 3 charts. Okay, this is descriptive. Remember, we asked for it. Okay, we asked for it. So then here you can see they have 3 group: morning, okay, and the afternoon, evening. Okay, they say we have 10 people. They are 10 participants. They have class in the morning, and 9 participants they have class at afternoon, and then 11 they have class at evening, right? Okay, and they give you the mean, standard deviation, and they give you standard error and all this stuff. Okay, the most important is this 3 part. Okay, this 3 part, and that is, you can see, looks like attendance rate is highest, right? See, 12.9, afternoon is 12.7778, and evening is 10.0000. Okay, and then you can see the standard deviation here. Well, when you see this data, can you just jump into conclusion and say, oh, looks like morning class, the student have a very best attendance? Maybe you can, but remember our goal is to see, are they different? Are they different? Okay, we are comparing, are they different? So when we compare the difference, we will use their mean score to take into consideration, but same time standard deviation. So you can see actually the score, standard deviation for evening, the range quite high. That means the attendance among students, they are very different. Okay, but the morning is more consistent. The difference rate is smaller, right? And then afternoon is like somewhere in the middle. But only this number, you cannot just jump into conclusion. You have to test, further. So that's why we use ANOVA. Okay, so we use this ANOVA, and this is different from T test, right? Different, okay? And this chart is important, okay? So you can see they give you sum of square, they give degree freedom, and degree freedom here, because we have 3 groups, right? So 3 minus 1 is 2. That's why you got a degree freedom 2. Within group, you have total 30 people, and each group people losing 1 freedom. So 30 subtract 3 is 27, okay? Then actually this divided by this become this number, this divided by this become this number, and then these 2 numbers divide become this F. Okay, so F is important number you have to be aware, and also SIG. So this SIG 0.010. Well, you remember our cutting point is 0.05. So compare with 0.05, actually this is very good news, right? This is very good news. This show they are really, really, really different. Okay, so actually this is important chart. We will need that in your paper, okay? So you can copy. Remember I show you in other video. You copy, you click your right side your mouse and say copy. Okay, now let's open a blank Word document, or if you are writing your paper, you can just open your paper in the right spot and then click paste. Okay, so this is your descriptive data for ANOVA. Feel free to make your type, you can say descriptive data for OneWay ANOVA. That'll be even better, okay? Then you go back to your SPSS. Now let's click this one and click right side your mouse and then click copy, and back your Word document, okay? And then paste. See, if you use this, you got something like this. This not what you want, okay? This, how about this? Yes, how about this? Yeah, so either this one or this one, they are pretty good, okay? So this is OneWay ANOVA, okay? That's your result, okay? So you don't have to create another chart. This chart should be good enough for your paper. if you want to add some more detail in your title, it's fine. But even you don't. Also, I would suggest maybe you label your table by number because you are going to put a lot of table in your paper. So if you can put some number like table 1, table 2, that will be even better. Okay, so you get to this part. Okay, and remember, okay, let's back to our PowerPoint. So then I give the step and I already demonstrate. So I assume you know what's going on. Okay, so if you are using independent T, you pretty much almost done, right? Okay, we are not done yet, but it's a good point to look at. Okay, so this is very critical point. If this number, let me see where's my mouse. Oh, I can point you to the right place. Okay, if this number is greater than 0.05, then you're pretty much ready to stop, okay? You don't need to go any further after you write your decision. But if this number is less than 0.01, you have more work to do. Okay, so let's go to next slide. Okay, so based on the data I just showed you, okay, remember they are less than 0.05, so that's good news here. So you write down, even greater than 0.05, you also need to write this part decision, okay? So here you will say, and OneWay ANOVA was calculated, compare the mean score of attendance for participants in different class times. Okay, so you compare all the mean score, okay, for those people. Then what happened? If you are less than 0.05, you will say a significant difference. If you are greater than 0.05, you will say not a significant difference, okay? So a significant difference between the means of the three groups, then you write down F. Okay, now this is a degree of freedom. Where are they from? Go back here. See, 2 and 27. 2 and 27, okay? Because this numbers come from this divided by this. That's why you put this 2 degree freedom there, okay? Here, equal 5.494, okay? Again, it's here. 5.494 is from here, okay? And then you say P less than 0.05. So the HO was rejected. Okay, so if HO was rejected, what does that mean? That means you reject this one. So when you reject this one, that means this one is supposed to be, right? So that means, hey, they are different. They are different. The point is, now the next concern is, then which one is different from which one, right? If we only have 2 groups, then we can just look at mean score and say, oh, this one is higher than which one. But this is the 3 group. Even the mean score gives you some idea, but you don't really know which one really different from which one, okay? So if you are running a OneWay ANOVA, please don't stop here. You need to go one step further, called Posthoc test. Called Posthoc test. Okay, that means you do further comparison for those 3 groups. You will compare their 2 groups, 2 groups, 2 groups. Okay, so it's not hard. Okay, let's back to our data. Okay, so you back your data and you go to the same place, exact same place you are running OneWay ANOVA. Okay, analyze, compare means, and you go to OneWay ANOVA. Okay, and then this all the same. Only different is now you have to click here called Posthoc. Okay, you have to click here called Posthoc. Okay, and Posthoc, so they have so many options there. You choose 2 key. Okay, you choose 2 key. Okay, because in our field we have everybody have pretty much the general common agreement that 2 key is pretty useful for many research. So we choose 2 key. Okay, And since we set 0.05 here, see that? Okay. Then you say continue. And you say okay. Okay. They will give you again the descriptive ANOVA, so you don't have to worry about that. Okay. Just now, this time is here. Okay. Multiple comparison. So you will see they are compare two group at one time. Okay, so let's copy this chart first, and I'll explain to you more detail. Okay, so click your right side mouse and say copy. Okay, and then you go to your Word document and go to place you want. Okay, and click paste. Okay, so let's look at this chart. Maybe I extend. Okay. Ooh. Okay, I think this is very good. Hopefully you can see them more clear. Okay. So you can see here. First of all, you compare morning with afternoon. Okay. Morning and afternoon. Now, this number tell you when those two mean scores subtract. So if you see the positive number, that means the morning attendance is better than afternoon. That's why they make the number positive. All right. Then you look at this number, SIG. This number had to be less than 0.05 to say they are really, really different. Okay, so did you see this one? 0.992. What's that mean? That means there are no difference, right? So you don't have to worry. Like morning and afternoon, they are slight different, but no significant. Okay, now you compare morning and evening. Okay, still positive number. That means your morning attendance is better than evening. How much better? Ooh, do you see the number? 0.018. That means they are less than 0.05. So that means morning attendance for morning class is significantly different from evening. 0.18. Okay, so keep in mind that's the part you have to put in your report. Okay, now this part is same as the part they just flip. They just compare afternoon and morning. So you can see this number same as this number, so you don't have to worry, they are the same. Okay, now how about afternoon and evening? Afternoon and evening, the number here is positive, so you don't have, so you know afternoon attendance for afternoon class is better than evening. 2.7778, that's their difference. Okay, now this number 0.029, what's that mean? Less than 0.05, so that means afternoon attendance of afternoon is better than evening. Significant. Okay, and then you can see here pretty much they are repeating. Okay, so you don't have to worry. And you can see the negative number. That means if when you subtract evening to morning, evening to afternoon, because they have a less attendance, so the number get to negative. Okay, so now it's clear. Hopefully this is clear for you. Okay, so now let's back to our PowerPoint. So then after you post the data, okay, so you have to post the data, right? Report this data. And then you have to say, okay, you have to say, so based on the result from post-hard test, okay, you find the mean attendance score of the morning group, or you can say morning class, okay? Then you report your mean and standard deviation. Remember, they are from your descriptive data. They are from your descriptive data. So go back to your descriptive chart. Okay, let's go back to see. Okay, here, right? Here. Okay, here, right? So you pretty much just report mean and standard deviation, a number from here, okay? Okay, so you say, okay, so you say the morning group, okay, morning group, here, mean and standard deviation was significantly higher than the mean attendance score of the evening group, okay? And then the mean attendance score of the afternoon group, mean and standard deviation was significantly higher than the mean attendance score of the evening group and mean and standard deviation. Okay, well, be careful. Sometimes students they they want to make them is a one sentence. They will say, for example, if you're morning group, they also different from afternoon and also different from evening. It's not the case for this one, but if that's the case for your research, please don't just say morning group or significantly higher than the mean attendance of evening and afternoon. Don't say them together. Remember, that's why we try to do the post-hoc. We have to compare two groups at one time, not three groups. So if you write them together, that means you go back to compare them together, and that's not make sense. Okay? So actually, this is the OneWay ANOVA. Okay, and then I also in your PowerPoint, I also post a link from YouTube. It's not from me, it's from somebody else. But then if you are interested to get to hear one more and from other instructor, professor, then you can feel free to use the website. Okay, so this is our OneWay ANOVA. So hopefully you find that helpful. So keep in mind, if your data is scale data, right? And then you are compare more than two groups, okay? Then you use OneWay ANOVA. Okay, so now your job is go back to the data I give to you if you are my student, and then you can practice, okay? See if you understand. Sometimes it's easy to just listen, but then when you start to do it, you may not find it's, consistent. But then once you feel you are able to run and get an exact same answer like me, you will be very happy, okay? And then after that, I want you to go back to your own data set, see how do you apply your research data by using this, so you can test your research result, okay? So hopefully this is helpful. If you still have more questions, shoot me email, okay? And so thank you, and I will make some more for other type of statistics. Okay, so I see you soon. Bye-bye.